Okay, hello everyone. Good afternoon. Okay, I think I will review so far, at least for the testing of the series. So as I mentioned last Thursday, we have several series which we are going to test and uh, determine whether it's convergence or divergence. So let's start with I think we could start with maybe number 11 and number maybe number 14, maybe one more. Or maybe try these two first, and then we go to the right side and try another two. So we try 4 or even 5 questions, and then we move to the new subtopics. Okay, number 11 and 14. Okay, try number 11 and 14. And maybe within this week, I will add another exercise. I will just take the last year midterm, or maybe 2 years ago midterm, just to give you some examples on how the midterm will be. Mostly, midterm will be based on chapter 10 and 11, parametric, polar, and this sequence series. Sometimes I add, if we have time, about factors, but I think I didn't expect that, so maybe 10, 11 should be okay. Because vectors and vector functions will be as a additional reference, which I think I will add as a bonus lecture outside of the class. So I will prepare some recordings and give you some additional information. Maybe just two videos. The first is about the vectors. The second is about vector functions. Okay, what do you think about chapter 11? Yeah, too much. I agree. But the way we solve is basically not that complicated. Not that complicated. Compare with if you see other part of calculus thing. 11 is not as much as the other one. Okay, for number 11, because the question is only asking convergence or divergence, it has this -1 with power of n, then you must be trying something related to alternating series, right? Okay, let's do that. Okay, remember, alternating series, the value for the sequence is decreasing, and then you need to make sure that the limit is 0. And how do we know the limit is 0? You can see that this is n squared, this is n cubed, greater in here, right? So it will be 0. Logically makes sense, right? Okay. Or if not, define all by the n cubed. This will be n, 1 over n cubed. This is 1, and then this is another one, and this will be 0, right? Okay. And I think we can try, maybe let me write here, number 11. So first we could see that if this is the value, now if we, like, if you want to know like what's happened in the series itself, this is something you could do. Like you could test 1, 2, 3, like just like a normal series. So you can test the n equal 1. So n equal 1, the a1 is 0, and then a2 is 4 minus 1 is 3 over 9, right? And then a3, this is something that you could do also. Like if you are no clue and then no time to prove, just do it and then make sure that it's correct. And then this will be 8. And you'll see that this is going to be greater and greater, right? It's going to be higher on the denominator, right? And you can imagine that if we increase 4 with the power of cube will be getting larger and larger, which means it is decreasing, okay? So this is just to prove that, okay? So I think we could agree that starting from the 4n, we can write that this is decreasing. And then limit for this an. Let me just write 0, okay, directly. And it's true, right? So this will be convergence. So series is convergent by alternating series. However, if the questions maybe ask further, like, we know that this is convergent by alternating series, but which one? Is it conditional or absolute? Then we could try to evaluate the series without the alternating sign. If you want. For example, we can check that the series, okay, be careful. The series like this, okay. So we have this series. So of course, what you can do about this? You need to think somewhere in your brain. You need to think of something. So how to know whether it's converged or not? Okay. If you have no clue now, you will not have any clue in the exam. Try something. Try to think. Okay. Try to think, and I believe the more efforts you try to think, it will help you not only in this course but helps you in life. Okay? It helps you in life. Sometimes I'm not saying like in every school, but I think our system of education, maybe not in all part of countries or maybe in the world, sometimes the education system is just to prepare students to become employees. So it's like a molding. So you are going to be molded by the teacher. Okay, you are going to do this. But what I want to approach, or maybe the world now are driven, the education is to let the students think independently. Okay, and when you do that, you have the freedom of choice to get education. Okay? Not because you are told to by your parents, but because you need and because you want. Okay? That's, I think, important, because I know that when I was young, I also think, oh, get education, get a high-ranking university, blah, 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 and then get salary, high salary. Well, that's one part, but there's another part that is yet to be discovered. Okay? And I think every one of you will have different purpose, right? And depends on which purpose, which value you be passionate for, that you need to answer that yourself. Okay? Do not rely on, like, every time we have lectures, do not rely on the professor all the time. Do not rely on TA all the time. Do not rely on your senior all the time. You need to, like, get on by your own power. Okay? And and believe me, when you do that, and you see the effort at the end of the day, the result is like you achieve the result. It will be really, really wonderful, and you will feel like no regret at all. Okay, now this you have. If I close this constant, it's just n squared and n squared, right? Which this is just 1/n. And say something about 1 over n. We can compare it. Whenever you have a big fraction with some additional context here, but you can see that, okay, we have dominant power. Use comparison test. Okay? That's when you use that. So use comparison test. Or if maybe sometimes like this one, I think comparison test is not enough because of the signs, this minus and plus. If they have plus, maybe comparison will be okay. But if not, then limit comparison test. I think still okay. So you could perhaps take the 1 over n as your comparison, because you could have the 1 over n, and 1 over n will multiply with the n squared, which we are going to see n cubed. So it has the same dominant power. Okay, we have now, if we, so let an become on the our questions, and then bn will be, we take 1 over n. Okay, we take 1 over n. And then taking the limit of the an over bn. So this, so I need to divide with 1 over n. So I will switch and then I will multiply the top with n. So, oh, I forgot the limit. And do you agree that this will be resulting in 1? Is resulting in 1, right? Okay, so it's positive, so it's greater than 0, which means that since bn, or sum or series of this bn diverge, right? 1 over n is diverge, then the an also diverge. Okay. So since this is diverge, but the ultimate thing is converge, this will be conditionally convergent. Okay? Diverge, converge, conditionally convergent. But actually this green one is not needed, not necessarily needed. This is if the question asking conditional or absolute. Okay? Okay? So diverge, but this is converge. So this convergent is conditionally okay. Okay, so again, remember, if you have like something like this, you have some extra polynomial, constant, whatever. Do not try to use with another, like, for example, ratio test. Will it be helpful here? I'm not sure. I think this is another clue that maybe you could compare. You could use comparison test. Okay. Okay, that's number 11. Okay, number 11. Now the second one, try number 14. Okay. Number 14. It is n with the power of 2n, and then we have the denominator is 1 plus n with power of 3n. That's also obvious, right? Yeah. Yes. Yeah, root test. It is pretty obvious. Why? Because I think every time you have a component in the series that is in power with n, just go directly try root test. Okay. So there is so there are some series that you could see, and then you can directly use some specific method. Okay. But there are maybe some other that you need to see like one by one. Okay, you can check one by one. For example, the easiest way to see is take the limit, and when limit is not 0 or doesn't exist, you could directly determine as divergence using divergence test. But if limit is 0, try another method. Okay, try another method. You could try comparison. You could try the ratio test or root test. Okay, so number 14, we take the root test. So let me write here, number 14. Maybe let me write here, up here. So we directly write as square root of, or root of n, and taking this part. So we have n squared over, oh, I forgot the limit. And 1 plus n with power of 3. And then, if you have something like this, you have like a component with a cube, because this is in the limit. Idea is, we know that this will be bigger, right? The dominant is 3. So we divide with the n cube. Okay? So which means we divide in the inside of the bracket, we divide by n. Agree? Agree? Okay, so we just divide that. So what I mean is we do not need to expand it. Okay? So this will be 1 over n. So we have this thing, a property, right? One property. So this will be what? 0, right? So this will be 0. It's less than 1, right? So the series, remember in root test, you can have positive greater 0, greater 1 or less than 1. If it is equal to 1, then you need to use another method. Is divergent by root test. Yes? Diverge or converge? Converge, right? Converge? Why I write? Oh yeah. Why I'm writing divergent? Okay. Sorry. Sorry. That's why I'm seems like. Yeah. Mix up. Okay. Sorry. Okay. Good. I just want to test this one. The truth is, I forgot. Not forgetting, but why? I don't know why. I think I'm writing. Why I'm writing? Okay, maybe this other number. Any number? Request. Maybe the one that you think is not really obvious. 33. One time at the moment. 33 or 24?
Can we try 33?
33, okay. 4 minus cosine n divided by square root of n. Okay, this is the difficulty increase a little bit. Okay, not a little bit, much. I think this one still okay, and then after the, I think after this is increasing. Okay, maybe 33. Let's try 33. Is we have 4 minus cosine n divided with the square root of n. Okay, any idea how to solve? Idea, not the solution, just idea. Idea can be anything. Take limit, okay. Can you solve with limit? No, yeah, don't take limit. Maybe other idea. But that's, I think, good effort, because basically the way you see the series, basically you can take the limit first. If you can take the limit, you can evaluate, try to find the value. If the value, a number, not 0, then it's divergent. And then finish, right? But if 0, then, oh, we need another method. Okay, okay, what should we do for this one? Remember, trigonometric value, the range will be from, yes? Yeah? From? Yes, -1 to 1, right? Which means that if we can perhaps make this at most, because the maybe the argument, okay, let me write the argument, because the cosine is from -1 to 1, in which this number compared to this 4 minus something here, this cos n, it doesn't really mean anything, right? Because it's still positive, right? It's still positive. So suppose that we only take this, suppose that cosine n is the maximum is 1. So let's say we take the maximum number, okay? So we can write a 4 minus cosine n. This is always greater or equal the maximum value of the trigonometric, right? Let's say 1. For sure, so it's 3, right? And this will be equal to 3 over square root of n. At least this is going to be true for n starting from 1, right? At least. And we know that the series of 1 over square root of n starting from 1 to infinity, this will be converge or diverge? Huh? Converge? Are you sure? Sure? This one? Can it go negative? Negative? No, it's negative. What do you mean negative? I'm sorry, no. No. I would like to know what's your thinking. Why? Okay. Okay, so this is the P series. We only have choices for the P series. The P series is 1 over n with power of P. The P, remember, the P, I will only give you these two options here. So we have 1 over n, 1 over n squared. Okay. Which one is converged? 1 over n or 1 over n squared? Which one is converged? N squared. Okay. So if it is greater 1, it must be converged. If 1 or less than 1, diverged. Is this diverged? Okay. So since this is diverged, and then our value here is greater than this. If this is diverged, then this should be diverged. Okay? Okay. So is divergent by direct, or just comparison test is okay. Comparison test. Maybe let me make this going up and smaller. Oh. Resize. Okay. All right, so 33 done. Maybe one or two more questions and we can go through. If you see something like the hyperbolic like this, I haven't yet explained since calculus 1, so you may skip 401. Any other requests? Which 42. This one? Ah, interesting. This is something that you need to make sure you know how to, okay? This will be really important. So whenever you feel, you see this, and that with the dot 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 on the number 25, and then perhaps number 23, what else? 36. I think, yeah, that is, or that one up there. There is something over there that this will be, obviously we can use one method. But let me ask you before I try this 42. Okay, so number 42. So how to solve number 42? I think it's pretty obvious, right? Pretty obvious, right? So it will be, we have power of n, power of n. I think we can agree this is going to be root test. Okay. I believe you can do it, right? Let's try another number. I think easy, right? You can check using root test. Okay? So let me write here first. Root test. But still, but it's interesting. Okay, interesting. Let me explain for you. Okay, let me explain for you. It's a little bit interesting for the solution. So root test, we can start with the limit so taking the an You can answer this using your logical argument. What do you think? Do you have factorials? Yeah, power 4. Without any calculation, what do you think?
Factorial is much higher.
Yes, 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 something like that. So you can see the arguments, right? So it should be going infinite number, which means it should be divergent. Okay. Yeah, that's okay. But sometimes if you need you need to convince yourself, we could try using the n factorial. For example, the n factorial, we can rewrite this n, and then n minus 1, right? Multiply, n minus 2, n minus 3, and then let me just n up till there, factorial, okay? Because it will be many terms, right? And what I want to do is just to make sure that we have, this is n with power of 4, but I will write this as each of this component. I will write something like this. It's n with power of 4, right? So n multiplied with n multiplied with n 4 times. So we can also write, this will be 1. This will be 1 minus 1 over n. This will be 1 minus 2 over n. This will be 1 minus 3 over n. And then you see that it's always increasing. We only get the convergent value here, but at the end, this will be increasing much higher. Like the same with our arguments that its factorial is much higher. Then you could write directly here it's diverged because of the factorial is much higher, and this makes the series diverge. And you could also show that okay, it has some convergent values here, but then it's going to diverge. So series is divergent by root test. Okay, so for something like this, you have a power of n for both numerator and denominator. It is obvious you can check the root test first. If you have a fraction, like number 36, you have 5 to the power of n, but the top is nothing, only just polynomial n squared. That is perhaps using the ratio test. And ratio test, since it is going to be our next subtopics, which we are going to expand the ratio test, which we call the power series. And in those power series, we are going to see that the convergence is not only about one point. It could be an interval. It could be interval. So we are going to see the interval of convergences. Okay, so that's the power series. So I will go there. Okay, I will take a new page, and hopefully, at least from the whole questions here, you can try more. Okay, you can try more. Let me know which part that you feel that you need more review. Okay? Like if you are maybe perhaps still confused on some series, let me know which numbers, and then I will try my best to discuss. Maybe not all questions, but maybe just a representative for those questions that you still might confuse. Okay. Okay. So let's go to this part. Okay. So power series. Power series. So what is power series? So actually the power series is basically it starts with this. Okay? You have a constant with the n, and you have x with power of n. That's the idea. Okay. So let's start with something that is we are familiar. Okay, we are familiar. So power series. So for example, if we have only x with power of n without any coefficient, we can write this as 1 plus x squared plus dot 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 plus x with power of n plus dot dot dot. And we know this is the same with our geometric series, right? This is also, we can say, also can be observed as geometric series, right? With a is 1, and then the ratio is x. And then we know that this will be converge when the ratio is less than 1, or absolute ratio is less than 1, or in terms of x, this will be negative. So let me, maybe here, let me move this a little bit left. So we know that it's converged when this will be true, or we have this. And then we have the sum of the geometric series when it's converged is a over 1 minus r, right? Or in our case, this will be 1 over 1 minus x. So I will give you some short summary that we are going to expand within this subtopics. So this is, if we think this is like a function, so our sum of this geometry, or of this power, can be written as a function. Okay. So our goal throughout this power series, and later we are going to have the Taylor and Maclaurin series, we are going to represent the series in terms of a function. Okay.
So, a one of the terms that we consider in geometric space is our condition.
Yeah, like I haven't explained all right this week. Okay, so that's our goal. Okay, so you could see that this some sort of becoming a function. Okay. So let's start looking at this, the whole definitions. Okay. So the whole definition, if we write here, when we have the coefficient, then we can write, and if we start from 0, this will be C0, C1x, and then it will increase the power and increase the coefficient also, the C1, C2, C3, the terms increasing. Okay? And then we could write, for example, the same geometric. We know that if we take the, if we put x equal half, then the x we can substitute. Then this will be v1 plus 1 over 2 plus 1 over 4 plus 1 over 8 plus da, da, da. Okay. And of course, we know that when x is half, it will be converged. And when x is 2, this will be diverged, right? This will be diverged. So it's 1 plus 2 plus 4 plus 8 plus 16. So the power series need to be started with the n equals 0 to make sure that all the coefficients start with 1. So that we can make it parallel with the geometric series. So this is converge. And then this is divergent. So then since with different x, it's result in different result. For the x in between negative 1 and 1, it's going to be converged. If x is greater than 1 or less than negative 1, it will be diverged. So there is something that is going to be important in this x. So we can write this x with another terms. Okay, I think we can have a break for a while and let's continue. Okay, let's continue. So the power series, we could write in more clear and more general with the term x minus a. So this means that if we have only x, we have only like one single value. You can check what's one single value like a function. But we want to know like if we have a perhaps the value that we want, we could make it into interval like this. So suppose that this is x, and this is x minus a, this is x plus a. So we could have something that in between that is defining our convergences. Okay, so that's why we need to write in terms of x minus a. So we call this power series in x minus a terms, or it's also called centered at a. Or power series about a. So if x equal a, then we see that all the terms will be 0. So we know that when this happens, power series always converges when x equal a. And then, aside from knowing about the terms x minus a, what we want to know is we can observe, like for example, we have some sort of series and we would like to know what is the status of the convergence. Not only divergent convergent, but we would like to know whether it has some interval of the convergences. Is there any difference? So to know the convergences, then because we are dealing with geometrically proven series, so I would like to say the power series is kind of like geometric as in it has the ratio that we multiply. For example, here's x minus a. So simply this series here is this multiplication of x minus a throughout the terms, right? Okay. So it means that in between these two and between these two, they have the same ratio. So it would be make sense if we test the convergences through ratio test. So we take the ratio test, take the next term over the previous term, n plus 1 over n, right? an plus 1 over an. So it's better. So we are going to take to determine values of x which the power series converges, we take ratio test. Okay? So basically, most of the time in power series, we are doing ratio tests and then we check the convergences. Okay? So let's try 3 examples to see some conditions that might happen. There are some products that might happen. Okay? So we take ratio tests. So first is, so I have 3 examples here. So we start from example 1. Okay, let's start from this example here, example 1. I think you can also check the textbook if you have. So suppose that we have the x minus 3 to the power of n over n. So now we are not dealing with, usually we deal on the x to the power of n, but now we substitute x with something related to x minus a. For example, we have x minus 3 with this, which means a is equal to 3 now. So to check the series, whether it's how converged it will be, where the interval of convergence, we take the ratio test. We take the ratio test. So take ratio test. So we take the an is x minus 3 with power of n over n. And notice that now we have some sort of x and an n. But when we take ratio test, we want to check the n, okay? So, like usual series that we have done before, okay? So we are going to take ratio test an plus 1 over a over n. So you will have x minus 3 okay. And then since this is going to be x minus 3 here, so I will cancel this with that, right? So, and we can factorize the x minus 3. Since this is, we evaluate n. We evaluate the series n. Okay. So we have, I haven't write the limit. I will write the limit now. So x minus 3. Well, let me write. This is supposed to be having absolute value. So absolute value x minus 3 and a limit of n plus 1. And we know that the limit will be 1, right? Limit will be 1. So we get that the result here, we can also write here, is x minus 3 in absolute value. What does that mean? What does that mean? Okay. It means that, remember, in ratio test, when the series will be converted, when the value is equal, yeah, 0 is over, but I mean the general is less than 1, right? Yeah, less than 1. So this will be converged if this is less than 1. Because we would like to know the interesting interval of the convergences, then we need to take this less than 1. Okay? So we take this. This will be converges if x minus 3 is less 1, right? So the interval, so the series is convergent or, but plus 3 is 2, when x is from 2 to 4. Okay. And series will be divergent if x is less 2 and x is greater 4. Okay. Okay. Okay, just to sum up for what we have here is, now the series is not only evaluating through the terms n, we are going to have another variable x, in which we already defined in the geometrical definition. And now we would like to know in which part of x that the convergence will be there. Okay. So to solve this, basically we are going to use ratio test to see the ratio between the terms, and then just similar with our regular ratio test, in which we take a limit of the n. Okay. So which means that every x component you can factor out, and you only take limit for the n, because that's the series that we are trying to solve, right? And then at the end of the day, this x component, we are going to make sure that it will be converged when it's less than 1. Then we get the interval. This we call the interval of convergence. This is what we call interval of convergence. Actually, it's not over yet, but let me just stop here and then go for the next example. And I will back to this point, because this is not exactly true, because sometimes it can be equal as well. But we are not sure yet. That is another thing. Maybe if we have time today, I will explain. But if not, then we can have like a general examples first, and then we go back to see the details. Okay. Okay. Now the next one is we have this factorial. N factorial x with power of n. The same with the previous example. We take the ratio test. Okay, we take the ratio test. So take ratio test. So we have, this is n plus 1, right? Because we can cancel the factorial with this one, right? And then x to the power of n we can cancel with this is x, right? So we have this, and let's take the limit. So I will factor out the x, and then this is limit. So I prefer to evaluate limit at the end, just to make the calculate or simplification nice and clean. And then we see that when we take the limit, this will be result infinity, right? So what's the consequences? What's the consequence of this infinity? Or let me write, maybe this is quite ambiguous. Let me just write the limit. Okay, the limit is infinity. Okay. How to make the series converge? Which value of x that might possible to make it converge? 0. But to make sure that we are not in confusion, why we can multiply with infinity? Remember, this is a limit. So let's say this is a number, a high number, which we regard. To make that number become so we make 0, we multiply with 0, right? So any number that comes up from here, we can make it 0. Any large number, and we say that this number is getting higher and higher, and we can write it as infinity. We can make this infinity gone with 0. Okay. So the only way we could say this series converges only when x equals 0. Okay, so this is another case. So when you take the limit, you evaluate its infinity, and you have this x, then this x can only be converged when it's equal to 0. This x means if we have, for example, it's maybe x minus 3, then x minus x equals 3 is the only way it's converged. Okay, get it?
But in terms of limit, if there multiply with infinity can be defined.
Yeah, that's why I already mentioned before. If I multiply there, I say, oh, I will multiply it with 0. It seems wrong, right? It seems wrong. So I say this is a new number that you can find. If we multiply with 0, it's 0, right? So that's the way that I explain it. Because this x and n is in the different role. You get it? Okay? If this is another n, same variable, that will be a different story. Okay? Get it? Not necessarily, because x and n is not in the same terms, I think, yeah.
But where are you going to put this 0? I mean,
If we take this with many numbers that we can find.
but it's not example.
Yeah.
It's infinity.
Yes.
It's one of the problems that what is faster, infinity or 0, which makes every number.
Zero. That's in this case it's 0. because x and n is different. N is in the terms of the series. X is any values that we find, not in the terms of the n, right? Right?
If we want to prove it, I mean, shouldn't we solve another limit where x tends to 0? And then solve this limit. Because
I think this will be true if I write this if this will be, I think what you mean is this will be infinity if x is not 0. Let me just write this. Okay? So that will be close, right? So this will be correct, right?
no, that's going to be a problem.
No, not a problem.
0 multiply infinity. It's DNA.
Yeah, but this is different variable. Different variable. No. Different variable. We take the limit here with n, and that is x, with this another variable that is not going to be the same with the n, right? That will be trouble if we have x, and then this is another maybe, this is another x like this, okay? And if we have another x here, like we have the this problem, right? We have this also problem, this also problem, right? But that is when we have the same variable x. Do you see what I mean?
Yeah, no.
Okay. So this is, we only take the limit only for n, which means anything that can happen with n, it will be gone if we doing something with x. So it's like a different world. Okay, you get it?
Really? Does it work so?
Yeah. For this case, it works. For this case, it works. Okay.
Okay.
Okay. Yes.
How do you cancel the factorial?
Oh. Okay. Let me write here. So n plus 1 factorial is n plus 1, and then this will be n factorial, right? So here, n plus 2, n plus 1, n minus 1, n minus 2. Okay, this is the whole factorial, right? So it means that since this is n plus 1 factorial, then we can write this as n plus 1 n factorial, and then divide with this. Cancel. Okay? Okay. Now the last example, this will gives us, so let me write this, another ratio test. Okay, another one. And remember, we have 2n inside the factorial, which means that the n will be 2, and then n will change to the n plus 1, and then close bracket and factorial. Okay, that's the n plus 1 if we change. And then this is 2n factorial. This is x power n. So we have cancellation on x. So this is, we have only x. So we have 2n factorial over 2n plus 2 factorial, and then this will be x in absolute value. Okay, now we can write the 2n plus 2 factorial as 2n plus 2, 2n plus 1, and then 2n factorial. So we can cancel the factorial, okay? And then take the limit. Let me write here. Take the limit. Let me move to the left a little bit. So take the limit. Or maybe let me write as absolute value. Limit. Now we are going to have the limit itself is 0 now, right? The limit itself is 0. So which means, what about x? What about x? Yeah, the only way, or not the only way, all the numbers is possible. So x will be for all values of real number. The limit is already 0. So we could write that since this is equal 0, okay, because of this 0, then series converge for all values of x. Okay, now from these 3 examples, okay, we can see that it can be interval of convergences, it can be an interval, it could be only x equals 0, or it can be for all values of x. So it will be three results, okay, or 3 conclusion. So for the power series, let me just write the conclusion first. Okay. So for the power series, there is only 3 possibilities. It converges when x equals a. It converges for all x, and then it will be having some interval of convergences, and it will converge if the x minus a is less than r, and we are going to see what is r, and then diverges if x minus a is greater than r. What is r? R, by definition here, is basically, we call that as a radius. So if we could see this line here, if we take our series center at a, which means the x minus a, then the r is the distance between a here, okay? And the whole thing here is the interval. Okay? So this is the interval of convergences. And the distance between this a to each endpoint is the r. Okay? We call that r as a radius of convergence. So r is radius of convergence. Which basically R will be the value when you do the ratio test and you get those values, the value itself will be the R. So you know the distance from the center to the endpoints of the interval. That's it. And then we could see the three examples here. We could start with the geometric series that we know, the x to the power of n, okay? And then radius of convergence, of course, it's just 1. We take the ratio test. And then convergences will be negative 1 to 1 because it's the ratio, it will be converged, right? When it's between in between negative 1 to 1. And then this is example 1, 2, 3 from what we have done before. The radius, this is 1, okay? And then now the interesting part is this has the equal to. Okay? So that is the one that I want to explain. Okay. So let's go back for a while. Okay, let's go back for a while. So this is not over yet. So this is what we can do is we check every endpoints. Check the endpoints. So we check when x equals 2, it means that we have the series. It's negative 1, right? Negative 1. Remember, in alternating series, we know, I think we have done before, right? This will be converged, right? Which means that we have equal. Okay. So we need to take the equal because this is converge. And then when the x is equal 4, the series become 1 over n only, right? Which means this will be diverges. So we don't include 4. So the interval convergence, the final result will be 2 less equal x less 4. And there are some cases that it can be like both diverges or both converges, which means it can be equal or it can be not equal at all, or both endpoints. What you need to do is check. Just plug in the x equal to x equal 4 to the series and then evaluate the series, which you have done from the testing series, right? Okay. Maybe any question before we continue? Too much? Yeah, of course too much. If not, then there is no calculus. Yeah, calculus always too much. But that's life. Sometimes you have something that is too much. Okay, so for this R, okay, we could also think like the x is actually the center plus minus R, right? For the interval and endpoints for the interval of convergence. So we can make this some cases, we can have the interval cases for, let's say, for interval of convergences. We can have one is a minus r, a plus r, with the open bracket. And then we can make perhaps something like this, and then close on the right. And then this is close on the left. Well, I think this is just logically makes sense, and I don't think you need to write all of this. As long as you know that there will be four possibilities. Okay, so after you get the radius, you get the interval, you need to check. Okay, you need to check each endpoint. So let's go for example here. Example 4. So you have negative 3 with power of n, and then x power of n. And then divide by square root of n plus 1. Okay, now let's see from this example, we could define which one is R and which one is our interval. Okay, so as usual, start with ratio test. Okay, start with ratio test. So ratio. Okay, so I think the x with power of n we can cancel, right? Cancel this, cancel that. So we only have x. And then negative 3 with power of n we can also cancel. So we could have negative 3. So we have negative 3x. And since it's absolute value, then we can write 3x. So 3x, and then we take the limit for n. And I think you agree that this will be 1, right? The limit is 1. So this will be 3 absolute value x. This will converge when less 1, right? So x and absolute value is less than 1 over 3. So what is this? This will be the r. Okay, so this will be the r value. So if the question asks radius of convergence, then this will be the answer. So radius of convergence is 1 over 3. And the interval means that we need to expand the x interval. That's the interval of convergence. So negative 1 over 3 less than x less than 1 over 3. This will be the interval of convergence. But we are not finished yet. So we need to check. So we can write this as interval, but we need to check x equal negative 1 over 3. So the series becomes and we can cancel the negative signs and it will be just 1, right? So we have yes, it's diverged, right? It's diverged. So we see that this is diverges. And then check the x equal 1/3. We get the alternating, right? So since alternating, limit is 0, it's decreasing, then this will converge, right? So finally, the interval of convergences will be -1/3 less x less equal 1/3. Or we can write -1/3 open bracket and then 1/3 close bracket. And do the same thing with this, the example number 5. I hope you could do the same thing. But let me just finish off example 5 and we are going to finish. Okay, we finish the lecture. I just want to know whether you get the point or not for the radius and interval of convergence. So if we take the ratio test again for example 5, okay, the same thing. We take this and that, this will be 9 and 3 and cancel 3, right? And this will be cancelled. This will be x plus 2. Okay. So we get the 1/3 and then x plus 2. And then we have limit. Okay. Okay, now if the question asks the radius of convergences, what will be the radius of convergences? So we can say this is converge if less 1, right? So how to know the radius of convergence? This part, right? But which one? What is the radius? So this should be less than 1 right there, right? So the radius is but it has over 3. So x plus 2 less 3. So 3 will be the r. Okay. And the rest will be the same. Okay, I will skip the rest, but the final result should be, after you check each endpoint, I will just write the conclusions. The interval of convergence, when you check, the only way it's going to be works is only this -5 to 1, both open brackets. Okay. So if we check each one of them, there will be a diverge. But you need to check by yourself, okay? And I encourage you to try by yourself, okay? Do not rely on any tutorial. Do not rely on your friend, your seniors. You need to check by yourself. Try one by one. Try from the beginning. If you just see the video and then you just think, oh, I can do that. I can do that. But when exam, how am I going to do this? So you need to try by yourself, okay? Because I have experience when I was still in your age. Sometimes I also think like that, so I know how you think. So sometimes when I ask my friend, oh, why this is blah blah blah. Oh, this is it seems that I understand. It seems when he I get it. But I need to check, right? I need to check my own limit, right? I need to check my own skills. I set time, maybe 10 minutes or 15 minutes for one question. And I know, oh, I'm still not understand this point. So I need to get back, try to catch up. So every time you have a concept, a new chapter, new topics, test yourself. Do you understand? Okay. If you need somehow like more resources, check the tutorials. But still, after you check, test again. Do not wait until I test you. When I test you, that will be the result for your score. Okay. So always test yourself. Okay. Test yourself. What is the expectations? Okay. Because I think most of the scores that you get from the first quiz, it is because there is some sort of skills that is not sufficient. Because I think everyone has a different background and skills, right? So now you know that you lack of something that you need to catch up. Because of course I won't like repeat all the calculus 1 or basic of math, all in the calculus 2 class. Right? So if you hope like I want a class that will be telling me step by step all the concept, I don't think we can do that. I can maybe mention some point that you need to check by yourself. Yes, maybe this is in calculus 1, blah blah blah. But I will not repeat all concept in one class or in the whole semester. Okay. So test yourself. Okay. I think I will give you the last year midterm to check, so you know how. And chapter 10, do not forget that yet. We still have the midterm which includes the chapter 10. Not over yet. Not over yet. Okay, I think we finished today.